Alright, so we're starting here looking at what says Calculus 8th edition, Larson. This is your textbook, but it is not your entire textbook. It is only the homework pages. In Canvas, it'll say the text homework pages online. It's a link to this website here. And if you want a certain chapter, you've got this drop-down box, and we're in Chapter 6. And we're dealing with homework problems from Section 1. So you're going to also get, like if you notice on this is problem number 1. If you click the little S, it gives you the solution and sometimes a little bit of step-by-step. So you can check all the odd problems. So this is really as good as bringing your book home with you as far as being able to do the homework. And I wanted you to see this because we're going to actually take a look at some problems that are from this and some of the wording from this. So I gave you the first little video, and we didn't use the book at all, but now we're going to be looking at a few more very specific problems. And if we just take a look at a problem like, say, number 11 to start with, y equals 6e to the negative 2x squared, and we know that y prime is negative 4xy and y of 0 equals 6. So we've got, this is our solution, this is our differential equation. So we have y equals 6e to the negative 2x squared power, and y prime is negative 4xy, and they give us the initial condition that y of 0 equals 6, and we're to verify this. So what we're going to do is we are going to solve this. We're going to do it kind of like we did yesterday. We want to know, is this a solution to this differential equation? And so we are going to start by just taking the derivative of this and seeing if we can then do some manipulation and make it match up to that. So the derivative, y prime, the derivative of e to the u is e to the u times u prime, which is negative 4x. That 6 just sits out there. So this is our derivative. Does it look just like that? Well, I want to see, does this look like negative 4x, well, there's my negative 4x, and y. Now y, this does not look at all like y, but isn't that y? So y prime does indeed equal negative 4xy. But we've got a little bit more information. We've got this, and we're trying to verify the entire thing. So could this be a solution to this differential equation with this initial condition? So it works out just fine. We can make the derivative of this. This would be a good possible solution to this differential equation, but does this initial condition hold? And this means when I put 0 into the function for x, do I get 6 out? Alright, so let's double check that. When I put 0 in for x, do I get 6? Well, 0 squared is 0, times negative 2 is 0, e to the 0 is 1, 6 times 0 is, or 6 times 1 is 6. So y of 0 does indeed equal 6, and so yes, we have verified that it is a solution to the differential equation. Alright, so now let's look at another problem, and we can go to our book. And this time we have another particular solution problem. Okay, so now we're going to look at another example, as I was saying. Y equals x squared times 2 plus e to the x, and we want to verify that it looks like this differential equation right here. So if we go, here's our problem. We want to basically take a derivative. I noticed that this differential equation does not have any y prime prime or anything, so I'm just going to be dealing with the first derivative. It's not a particular solution because I don't have anything like y of 2 equals something. So I just need to, in general, see if this is a solution to this differential equation. So I'm going to take the derivative of this, so y prime, and to take this derivative I'm going to need to use the product rule. So x squared times the derivative of 2 plus e to the x would be x squared e to the x plus 2 plus e to the x times the derivative of x squared, which is 2x. So there's my derivative. I need to see if I can rearrange this somehow to make it look similar to this right here. And so I can see that I've got to do a little bit of rearranging with this. I've got the y prime is not by itself as it is here. It's here by itself. So I'm going to try to manipulate my derivative to make it look like this. I suppose that I could manipulate my differential equation to make it look like this and verify it either way. So what I notice is I'm going to multiply both sides by x. I notice that my y prime is multiplied by x, so I'm just going to take both sides of my entire equation and multiply it by x. That's a perfectly legal move. So now I'm going to have the xy prime. I'm going to distribute this x, and so I'll have x cubed e to the x plus 2x squared times 2 plus e to the x. Alright, so now what do I notice? Now this is looking much more like this, and it would want to stay on this side, and the rest of this mess should probably move to the other side because of that term right there. So I'm going to move this over. It does become minus 2x squared times 2 plus e to the x equals x cubed e to the x. So with a simple maneuver like, hey, I notice that the y prime is multiplied by x, I multiply both sides of my derivative by x, I then end up magically, kind of, that's just the way math kind of works sometimes, with these two matching up. Now I just need to see, is this that I have left negative 2 times y? So y was this right here, which is the same as that part with the 2 in front of it. So I can then say that this xy prime minus 2 times y is equal to x cubed e to the x, which then verifies that this is a solution to this differential equation. What if we have a slightly different? This time we have y equals e to the negative 2x, and we want to verify that it is a solution to this differential equation. Now what I notice about this differential equation is that it does have a fourth derivative. So I'm going to need to find the fourth derivative of this and then manipulate that fourth derivative and see if I can make it look like that. I'm going to be using the fourth derivative and this original function. So the first derivative is going to be negative 2 e to the negative 2x. The second derivative is going to be 4 e to the negative 2x. The third derivative is going to be negative 8e to the negative 2x. The fourth derivative is going to be 16e to the negative 2x. So I need to take this and manipulate it so it looks like this. So I've already got the y to the fourth. So if I just move this to the other side, that should be getting me closer. And the only difference is now that this is y and this is e to the negative 2x. Sorry, the only difference is now that this is y and this is e to the negative 2x. But it does so happen that this is y. So I can replace that with y. And I have then verified that this is a solution to this differential equation. If you cannot do the manipulating and get it to work out, then this is not a solution. And we'll look at that in the next video.